if the equation of the regression line for the day's high temperature X and the mean number of robberies committed that day is this, then on average, days with higher temperatures also tend to be days with a greater number of robberies. Is that true? I mean, is that what the equation is saying? Let me write it out. Oops, it's not an 8, it's an X. Okay, so just bring that equation down like this. Okay, remember y equals mx plus b. This is the slope. This right here, we call it m, it's the slope. So the number next to x is the slope. In this case, it's 0.3. Okay, and so what? What is the slope? Well, the slope, remember, is, do you remember from your earlier math classes? Slope is rise over run, where rise is the y values, run is the x. We mean like on a graph, x-axis is sideways. So y is a rise up and down, and x is run, like you run sideways. Rise or run. And now what you do is you put the slope over 1. Now why? Why don't you put it over like 3 or 5 or 19? Why? Because it doesn't change it. If you put it over 19, that would change it, or anything else. But if you put it over 1, right, any number divided by 1, dividing by 1 doesn't change it at all. So, okay, so what? Well, that way we can make it look like a fraction, so we can tell what the number on the top and the bottom is. Does that make sense? I don't want you to see that as some magic trick. Anything divided by 1 is the same as itself, right? Like take 7. What is 7 divided by 1? 1 goes into 7 times. It's the same thing. Dividing by 1 doesn't change the number. Okay, but why do we do it? Because we need to see two numbers. We need to see a top and a bottom. Why? Because that's what slope is. It's rise over run. So we need to see this 0.3, which is one number. We need to look at it like it's two numbers without really changing the value. So you put it over 1. It hasn't changed a thing. It looks like two numbers now, but it's still the same value as 0.3. And now we can identify the top and the bottom, which is what slope is, rise and run. So we can see that the y value is 0.3, the x value is 1. What are y values? I don't know. The equation works on for the day's high temperature is x. So this is the temperature, okay? And the mean number of robberies. So mean number of robberies, that must be, y. Yeah, it does say right there. It says y. Didn't realize that. Y. Mean number of robberies. So number of robberies. Meaning the average number for different cities. So in other words, this is positive, and this is a positive slope, isn't it? Right? These aren't negative numbers. So that means the number of robberies goes up, positive, up, when the temperature goes up. Is that what they're saying? Then on average, on days with higher temperatures, tend to be days with greater numbers. True. That is true. That's what that equation is saying. That line equation that's connecting x, which is temperature, with y, which is number of robberies. Rise over run is slope. The slope is 0.3. It's positive. It's positive, which means up, which means robberies go up as temperature goes up. Now, so temperature is causing robberies. Well, just because two things are connected doesn't mean one is causing the other. Remember how we talked about that? You want to be careful. Association is not necessarily causation. So in other words, why would higher temperatures mean more robberies? Well, when it's freezing cold outside, people don't go outside as much, and so they don't tend to rob things as much either. It's not that the higher temperatures are causing people, it's hot, I got to do a robbery. That's not what's going on here. It's the fact that on hotter days, yeah, more people are outside and more theft happens during that time. So it's a connection, it's not a causation. It's an association, it's not a causation. But that slope, being a positive slope, does tell us that one thing goes up when the other goes up. That's a positive relationship. Robberies go up when temperature goes up. True. That is what it's saying.